Hmm? এরকম আছে। What is periodic waveform? A periodic waveform is a signal that repeats. What is periodic waveform? A periodic waveform is a signal that repeats itself over time at regular interval and displaying the same shapes and non-periodic waveform. A non-periodic waveform, also known as a periodic exhibit or repetitive pattern does not exhibit a 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 repetitive pattern and lacks a well defined period. Periodic waveform be characterized amplitude. Periodic waveform can be characterized by amplitude, frequency, and phase. Can you provide example of periodic waveform? Periodic waveform. Example of periodic waveform in sine waves. Sine waves, square wave, triangular wave. What are the characteristics of periodic waveform? Non-periodic waveforms do not have a fixed pattern and their shapes, duration and amplitude can vary unpredictably over time. Can you provide example of non-periodic waveform? Example of non-periodic waveform include noise signal, random pulses and transient waveform. How it how is a voltage waveform different from a current waveform? The voltage waveform represent the the variation in voltage over time. The voltage waveform represent the variation in voltage over time, while waveform represent the variation in current in flow over time. Voltage waveform represent the variation of voltage over time, while current waveform represent the variation of current variation of current in variation of current waveform current flowing voltage and current waveforms are typically out of phase, meaning they they reach their peak value at different points in time. They reach their peak values at different times value at different point in time. They reach peak values at different point in time. What are the application of DC waveform? DC waveform find application in batteries, electronic device and system require a steady and constant power sources. What are the application of AC waveform? AC waveforms are used for power transmission, distribution, and in electrical applications and equipment such as motor, generator, and home electronics. How do DC and AC waveform affect electrical device differently? DC waveform provide a constant energy supply, while AC waveform allow for the transfer of energy over long distance. DC waveform provide a constant energy supply, while AC waveform allow the transfer of energy over long distance and facilitate the operation of many electrical devices. How are DC and AC waveform DC waveform can be generated by batteries or DC power supplies by batteries or DC power suppliers, while AC waveforms are typically generated by alternator or power grid system. Typically generated by alternator or power grid systems. What are the advantages and disadvantages of periodic and non-periodic waveforms? Periodic waveforms are easier to analyze and manipulated mathematically, while non-periodic waveforms are more representative of real world signals but can be more challenging to voltage and current sources. Voltage and current sources are fundamental component in electrical circuit that provides a steady supply of voltage or current sources. Voltage and current sources are fundamental component in electrical circuit that provides a steady supply of voltage or current. Voltage and current sources are fundamental component in electrical circuit. Voltage and current sources are fundamental component in electrical circuit that provides a steady supply of voltage or current. What is the ideal current source? Voltage and current sources are fundamental component in electrical circuit that provide a steady supply of voltage or current. What is ideal voltage source? The ideal voltage source is a theoretical maintain a constant voltage regardless of the load load connected to it. It can provide infinite current when needed. What is ideal current source? The ideal current source is a theoretical component that maintain a theoretical component that maintain a constant current regardless of the load, a constant current regardless of the load connected to it, regardless of the load connected to it. It can provide infinite voltage when needed. It can provide infinite voltage when needed. What are non-ideal sources have limited only exhibit slight variation in voltage or current depending on the load connected to them. They have resistance or impedance. What is an independent source? An independent source is a source that provides Independent source is a source that provides a fixed value of voltage or current that is not dependent on the various variable in the circuit. What is dependent source? Dependent source is a source whose value is controlled by the voltage or current of another. A dependent source is a source. A dependent source is a source whose value is controlled by the voltage or current of component in the whose values are controlled by the voltage or current of another component in the circuit. What are the some dependent sources? Example dependent sources include voltage control source, current control control voltage source, voltage control current source, current control current source. How are independent and dependent sources used in circuit analysis? Independent sources provide circuit, while dependent source allow for the for the more complex relationship and can be used to represent amplifier sensor and is source transformation. Source technique used in circuit analysis to convert a voltage source and series resistance into a source, current source and parallel resistance or vice versa. What is the source transformation useful in circuit analysis? Source transformation simplifies converting voltage source to a circuit source or vice versa, making it easier to apply different circuit analysis techniques such as Kirchhoff's law or mesh analysis. Can you provide example of source transformation? Example of source transformation is applied a voltage source 12 volt in series with 4 ohm resistance 3 ampere. What are the benefits of using ideal source in circuit analyzer? Ideal source simply circuit analysis by providing to simplify the circuit analysis by providing constant and and predictable voltage or current values, allowing easier calculation and understanding of circuit behavior. What are the drawbacks of using in real world application? Ideal sources account for the limitation of real world component and may not actually represent the behavior of practical circuit. How do non-ideal sources affect circuit performance? Non-ideal sources may introduce voltage drop or limited the session which gives. Source provide a necessary energy and signal to the operation of electrical circuit. EMF refers to the electric difference. EMF refers to the electric potential difference. Electric potential difference measured in volt. Electric potential difference measured in volt that that drives the flow of electric charge in a circuit. Potential difference. EMF refers to the electric difference measured in volt that drives the flow of electric charge. That drives the flow of electric charge in a circuit. That drives the flow of electric charge in a circuit. That drives the flow of electric charge in a circuit. That drives the flow of electric charge. That drives the flow of electric charge in a circuit. That drives the flow of charge in a that drives the flow of charge in an electric circuit. That drives the flow of charge in electric circuit. What is current? Current is the flow of electric charge in a circuit. Current is the flow of electric charge in a circuit measured in ampere. It is represent the rate of current is the flow of electric charge in a circuit. Electric charge in a circuit. What is potential? Also known as voltage. It is the difference in electric between 2 points. It is the difference in electric potential between 2 points. It is the electric difference between 2 points. It is the difference in electric potential between 2 point in a circuit. It is a difference in electric potential between points. Is measured in volt. World donors moving between those points. How EMF, current, and potential difference related? EMF is the driving force that causes the to flow in a circuit. EMF is the flow of current in a current to a flow in a circuit. Current is the actual flow of electric charge. Current is the actual flow of electric charge, while the potential difference represent the energy difference per unit charge at the charge that drives the flow. What is power? Power is the rate at which the work is done. The work is done, or energy is transferred. Energy is transferred in a circuit. Power is the rate. Power is the rate. Power is the rate at which work is done. At energy, work is done. Which work is done. Power is the rate at which work is done or energy is transferred in a circuit. It is measured in watt. It is calculated by multiplying the current flowing through a device by the potential difference across it. By the potential difference across by the potential difference across it. How is how is power related to the current and potential difference? Power is directly proportional to the both current and potential. Current power is directly proportional to the both voltage and potential difference. The greater the current or potential difference, the higher the power. What is the energy in the context of electrical circuit? The electrical circuit energy refer to the ability to do work or transfer the charge. It is supplied by the source and is converted and utilized by various devices connected to the circuit. How it how is energy related to equivalent to the 1 watt second? Electrical energy is joule. The unit of energy in electrical circuit is joule. How is the joule? How is energy consumption measured in practical scenario? Energy consumed in practical scenario is often measured in kilowatt circuit. It is device has a 2 ampere current has a current of 2 ampere flowing through it and the potential difference of 12 volt across it. The power consumed by the device is equal to IV 2 ampere. But if the device operated for 2 hours, then the energy consumed per unit time 48 watt hours. How is the power related to the power represent the rate at which the energy is consumed. Power represent the rate at which the energy is consumed or transferred. Power represent the rate at which the energy is transferred or consumed. The power represent the rate at which energy is transferred or consumed. A higher power indicate a faster rate of energy consumption. How is power calculated in circuit with resistors? In circuit with resistor, power can be calculated using the formula P is equal to I square R P is equal to P square by R. What is the role of power in electrical circuit device? Power is essential for the function of electrical device as it determines how quickly energy is consumed or transferred, which impact the device performance and functionality. How is power efficiency measured in electrical devices? Power efficiency is measured by comparing the useful power output of a device to the total power input. It is expressed as a percentage and indicate how efficiently a device convert input power into useful output power. How what factor can affect the efficiency of electrical device? Factors such as resistance loss, heat dissipation, electrical losses, design consideration can affect the efficiency of electrical device. How can power and energy calculation can be optimized?